Okay, so we're going to start with footings, which is a great place to start, obviously. We're going to build our building above that. We have a Canadian design guide that has all kinds of information in it as to how the dowels should be placed, what size they should be, whether 10M or 15M, how much they're supposed to be put into the footing based on the design required. And what we do is we have charts that tell you how to space it out based on our ICF blocks. So in this particular case, you would find the actual block you're working with, get some of the measurements inside, outside, 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 and start laying out where these vertical dowels are going to be. In this particular case, you got your 8-foot, 11.5-inch inside, outside. You got your 10-foot 2 outside, outside, and you lay it out and start laying the dowels in place. When they get wet set or pre-tied, depending on what you're going to do on your site. So this one here shows it after the pour, obviously, but sometimes they get tied in place before you pour, support it, leveled up, and then you pour your concrete. Other times you simply pour your footing, have it all marked out, and set your wet set your dowels into place. This particular slide shows starting with the corners, as we always do. Start from the corners, move to the center of the walls, and it illustrates that your rebar is missing your webs, and it's also in the cavity where the concrete's going to go. I jokingly tell people when they ask me where the rebar dowel should be, I said wherever the concrete is. I don't want it coming up through the foam, but realistically, it's just a matter of making sure that it's in that cavity so that it gets encased with concrete and ties your wall to your footing. So there's what it looks like with complete row around. Rebars are still sticking up because in most cases they're approximately 24 inches above the footing. That allows you to get a really good splice overlap with the vertical rebars that you're going to put in the top of the wall when you get to top of wall before you pour. And the second row continues on the same way. And obviously you can't see the dowels anymore. But again, once you get to the top of this wall, you'll be setting your verticals in there. It'll create the rebar lap splice that's required to connect your wall to your footing properly. Two illustrations of footings, this basement on the left, an actual frost wall on the right. So what happens here, again, it illustrates the bent dowel on the footing. Same situation with the frost wall, the only difference being on the basement, obviously you're going to backfill to a certain height on the outside of the wall with your slab on the inside to help with that shear protection. And on the frost footing, you're going to have backfill outside and inside to come up and carry your slab. You can also do what's called a frost protected shallow foundation. That's a situation whereby you can't get a full depth that's required for the frost protection in your area. So we deal with this by having horizontal rigid insulation on the outside of the wall at whatever depth is available to work with. So in the particular case here, you've got the left-hand side. It's a regular ICF wall down to a standard footing. The insulation is tapered outward from the outside of the wall to allow for frost protection. And the one on the right-hand side is what we call a thickened edge slab. So again, you have your insulation under your slab, but on the outside of the wall, which is not protected, and you may not have the frost depth, you have to do that horizontal rigid insulation to achieve this. The other way to work with ICF blocks is if you have to scribe to bedrock. What you'll end up doing is you'll have your dowels, you'll drill, lay them out, drill them, epoxy them in. That gives you a connection to your bedrock. What I like to do is get my second row set up, leveled, and then we measure down and scribe the blocks to fit underneath that row to come down to the bedrock as best possible. And then you may have to use some vertical stakes or whatever to keep it stable. But realistically, you're scribing to match the ground, and it's quite easy to do because you're working with EPS.